We'll practice finding the period, frequency, and maximum speed of a mass spring system in simple harmonic motion. Here's the problem. A 0.50 kilogram mass on a spring with spring constant 200 newtons per meter oscillates in simple harmonic motion with an amplitude of 0.10 meters. Find the period and frequency of oscillation, and find the maximum speed of the mass. First, find the period using the formula for a mass spring oscillator. T equals 2 pi times the square root of m over k. Plugging in the values, we get T equals 2 pi times the square root of 0.50 over 200, which is 2 pi times the square root of 0.0025, which is 2 pi times 0.050, giving 0.31 seconds. Next, find the frequency using f equals 1 over t. So f equals 1 over 0.314, which is 3.2 hertz. Now find the maximum speed using Vmax equals a omega, where omega is the square root of k over m. Plugging in Vmax equals 0.10 times the square root of 200 over 0.50, which is 0.10 times the square root of 400, which is 0.10 times 20, giving 2.0 meters per second. Remember, for a mass spring system, the period depends only on mass and spring constant, and maximum speed equals amplitude times angular frequency.